test. I said test and it scared away one viewer. Nice. Oh, neat. A bunch of slash commands. Okay. Good to know. Some other stuff. Do-ba-dee-doo-doo. Trying to get started. Hello, thingy. All right, why is this not working? Part of it's working. Oh, wait, maybe I can monitor. How do I live dashboard from YouTube? I don't know. This is on YouTube and Google at the same time. How do you work? Sorry to everyone that's bored just sitting there looking at this. This is the first time I am doing this on both Hangouts on Air and YouTube at the same time, apparently, and yeah, it's a little weird. I love how YouTube is saying my current bitrate is lower than the recommended bitrate, but I'm streaming to it from itself. So it's like, don't really... Save changes. Yay, whatever. Okay, so I can only see chat if it is in the Google chat. I cannot see chat if it is in the YouTube channel. I'm trying to figure out how to make that happen, but I don't think there's any way to pull this off. Which is really a shame. What up, Jesse? Okay. So, yep.
Hey, Brendan.
Yo, people
How you
can
doing?
talk and stuff.
Sorry, what?
I said, what? People can talk and stuff.
Oh, yeah, sorry, did you not intend that I can mute myself?
So, I have no idea. Oh, Jesse's got his XSplit thing running, but it's just the XSplit whatever.
Yeah, that can be a default video thing sometimes. It has been for me in the past, too.
All right. So I'm just trying to see what I need to do to okay, so what? All right. Ta-da! It's a synthesizer, and it needs to be configured. Why does it say I only have one viewer if there's obviously two people in the, well,
Maybe
now
it's
it just changed. I don't even know. I don't understand the thing. I'm just trying to record this somewhere where it will be archived because I only have like a gig of hard drive space.
I know that feel.
So it's like that needs to go somewhere. Let's see if all right, I need to click a few more things and then it's time to get started because it's like 4 o'clock and this needs to be, I'm hoping to be done by 6-ish. I don't know.
By the way, it shouldn't, but let me know if you hear this. Okay? Oh shit, that clicking, did you hear that?
Yeah, I was going to say I do have that. You can just, if you want, you can mute your mic and type in the chat if you prefer or whatever.
Yeah, whatever you prefer, honestly, it's your stream. But I'm just trying to figure out a way to. It always says this. If that's coming out the. Let's open the volume mixer. Line in. Okay. That would do it.
All right. So I am gonna just.
Hey, someone else here.
Ah, Word. Tarun, how you doing? Let's wow, my laptop is like a slow piece of crap. Okay.
Hey, just curious to see what you guys are up to.
Word. Well, today is well, you see this picture of the thing that wherever my finger goes. Yeah. Anyway, so I guess I could like introduce this since there are actually people here now. So my knowledge quest or whatever with chiptunes has gotten decidedly more hardcore. And what I want to do is be able to, instead of just running emulators and trackers and whatever, I have decided that I want to actually like put sound chips from old systems in these boards and figure out how to drive them over USB. So we built this board right here, and right here you can see a chip that is an AVR. It's an Atmega 32U8, and up here you can see, well, you can sort of see it's really small. It's an AtTiny 85. And obviously over here we have USB, and over here we have audio jacks. And then I just have like a slew of breakout pins so that I can connect things to other things so that I can figure out how these sound chips work, right? So, oh, and up here is, once I can see my finger, this guy is an oscillator. It's just a crystal. So we'll end up connecting a line from this guy down to the main chip. Actually, so I can give you an idea of what this will look like when it's done, which is that guy right in the middle there. That is a mostly finished board that has an Atari Pokey in it. And in theory, it works. So we're going to try and do the same thing with this guy right here. And I recently just got this thing, which is a nice static bag with some chips in it. And one of the chips, well, we've got a couple chips, right? So I will show people what I got. By the way, Charles, before you sit down, can you tell me, is there anything like the little fork-looking silkscreen markings. What is
capacitors?
Is the fork thing just to indicate capacitors, or like what?
2 parallel plates, 1, 2, with wires coming off of them, indicate a capacitor.
Oh, okay.
These
So
two
you're
little
just
ceramic dots up here. Barely see them.
right. I mean, so it's just. I mean, this is the left side and the right side of each capacitor, right?
Right.
And then both of the pins are interconnected because of the way you have the plating. All right.
Yes.
All right. I'd never seen that, so I'm obviously a noob in some cases. So, things we got out of. Oh, Charles has produced a light. By the way, this guy. In a second, you'll see him. Hey, look, it's Charles. He is on YouTube as CN Lore, and he is actually the designer of this board. I gave him some specifications and told him what I wanted to do, and he kind of whipped this up in what, Eagle?
KiCad.
Oh, okay.
Eagle is commercial.
All right. So he whipped it up overnight, and like sent it off. He sent me the like all of the CAD diagrams. Does this look nice? And I'm like, yeah, sure. I don't have any idea. But we sent it off, and it appears to work. This is actually a first revision board. We have a revision B, which you can see over here. It's pretty much the same, except that we realized a couple things. One, this over here is actually on the board backwards in revision A, and also we wanted a few more breakouts and that sort of a thing. And we made, well, technically it's modular on the other one too, but once it focuses, maybe it won't focus. There we go. We're working on modular crystal instead of that one's just soldered on, because why the hell not? So I'm going to back this up a little bit.
This cat is infuriating me. What's he doing?
Things. We have a cat in the house. He might make an appearance.
Desperately wants to get
So Evan asks, what exactly does this board do to convert to USB? Yeah, I kind of went off on a tangent, right? So right here we've got the Atmel chip, right? You can sort of see that. The Atmel chip runs firmware, which we flash over those pins right next to the Atmel chip. And it has a USB driver in it, and the firmware that we wrote basically accepts commands over this USB cable, which will eventually be plugged in over here, and we can send the chip register values and that sort of a thing, and then the register values will just get sent directly to the chip. A lot of synthesizer or sound or chiptune projects or whatever try to accept a MIDI signal and MIDI clock and MIDI data over a MIDI cable, and then figure out what data to send to the chip to basically get it to produce notes that you tap on a keyboard, or play on a MIDI guitar or whatever, and maybe capture things like velocity or aftertouch, so that you can like hit note, basically sound notes louder or softer, or capture the mod wheel so that you can do some sort of vibrato thing, and that's all fine and good. But I want more low-level access to the chips. I want to be able to do stuff like explore the registers that would not necessarily make sense to map to MIDI keyboards, and I want to do other stuff like have direct access to the chip, so that, for example, if an emulator author wanted to write support for one of these boards in, you could plug in a board, start up an emulator, and actually using the emulator, you could use this soundboard as like a literal soundboard. Like the emulator could pass all the register values that it would normally pass to the sound chip to this board, and then you could get authentic output instead of emulated sound chip output. And hopefully we could just, I mean, for purists, that would just be a way to get the actual sound, and for people on a knowledge quest like me, and maybe the emulator authors, that could actually be a way to like learn about where the emulation is accurate and where it isn't. We could compare the emulator's internal sound emulation to one of these boards and see if the emulation is the same or different. And someone is at our door. Fortunately, there are a bunch of people in this house, so you might hear some hubbub. But so
I'll be ready in a minute.
hopefully, so this is a soundboard. I wouldn't expect it to go into a retro console. Oh, hey, it's an Eric Holniker. You want to say hi to a live stream?
Yeah, sure.
And be famous. This guy is Eric Holniker. He is now sideways.
Hey.
Well, maybe he is. I don't know.
Hmm.
Can anyone see Eric, or did this just lock up?
Looks like it locked up, bro.
I don't know. Maybe my screensaver kicked in. I see my mic thing. I don't know. I'm just running a laptop.
Oh.
Hi, Eric. I can see him.
Spooky.
Oh, yeah.
I'm all out of focus and sideways. Here, I can fix
whatever.
this. Ah,
Ta-da!
hey. Guess what's in the party
Shout
box?
outs for what is in the box. Show me
party
things.
box.
It's a party box. What do we have in the box?
What
This
does it look like?
I don't,
Other than my
I don't
keys.
know how to.
There you go.
Yeah. What is in Eric's box? I don't even know. It looks like a Virtual Boy that's busted up to hell.
That's a lot of them.
A lot of Virtual
A lot
Boys.
of Virtual Boys.
What are you doing with Virtual Boys?
Fixing them.
Fixing Virtual Boys with Charles, or?
Yeah.
Okay. Cool.
What's the thing? Oh, I stuck my cat.
Yeah, look out for the cat. The cat is kind of... Here, does everyone want to see the cat? Maybe. There's the cat. That is Cass Kitty. Cass Kitty may be high on catnip, or just life.
Hello.
Oh, yeah, it's going to look like
Right.
crazy stuff unless we take it out. But there's 4 units in there, and 2 of them...
All right, so behind me is Virtual Boy Repair. All right.
Scary little dudes.
Let's go back to what I'm going to put in this board. So chips that I have obtained. This is completely out of focus.
Problem is, it's not...
Hopefully you can see it. It says R6507H.
This cable to the PCB.
And also we have
So you can kind of see where it's lifted off. It's not making really good contact.
something that says,
It, like,
well,
just
maybe
like
you can
backwards
sort of,
or like horizontal
an
line.
8214, which says C010750-03. And then we have the chip that we're actually going to put in this, and this is the true giveaway. This is a C010444-22, which also has a copyright 1981 Atari on it, and is manufactured by Oki. So, anyone that wants to take any guesses as to what that is, you don't have to Google it. But
Dissolve it on the back, not this side?
Correct.
Why not this
so I'll take some guesses, but for now we're actually just going to take that chip and plop it in the middle. It smells like bacon.
Oh, okay. That makes sense.
If you,
That's not nearly as scary as I thought.
you can pull up there's a site where a guy talks about doing it.
Okay, I'm going to do that with a soldering iron, though, instead of...
Ta-da!
Because this
Everything's built. Stream is over. No, just kidding. All right, so
You want to be really careful with the soldering iron because within the cable.
that is that board. Now it's falling over. Whatever. All right. So
I'll bring it into
we're going to program this. I have no idea which way the programmer gets plugged in, but it'll just work one way and it won't the other way, so that's fine. Plug USB cables in the right way. Hey, what do you know? So we get LEDs, which you can probably sort of see. Yeah, that probably.
Very small plastic container.
Ta-da. And then over here, I've got some code, right? So maybe I should be looking at some of this. Can't tell if you can see.
Such a product ever exists. I know.
Is this backwards or the right way? I don't even know. On my end, the video looks flipped. Is the video flipped?
Really? Yes, yeah. You get one in each eyeball.
Anyway,
Oh, that's how they
we're gonna like pull up a USB descriptor thing, and if you haven't already guessed, it's out of 2600. So I'm actually going to give it a USB product ID of 2600.
They said sodium hydroxide, right?
Hopefully.
Correct. Okay.
Oh, cute.
Yeah. I'll bring in the screens.
I don't even know. Charles, I got a question for you.
He's down here.
Oh. I have no idea what LTO support is. LTO support? LTO.
So what we're gonna
We're comparing scissors here again.
There's one on the table right here. Do you want them? Okay. So I've been told that LTO support is not required.
Big box.
Just
Ship this.
nice. Ta-da! So we just kind of take it out. Make. All right. Something is unhappy. Well, not entirely. I don't think that that is. This is interesting. Well, I suppose while hey, Patrick has joined us, or a vampire. You can see his ceiling fan. It's very tantalizing. All right, well, we're going to just switch and do the other thing, which is let's wire this baby up. And that means I need a pinout. I can hear your microphone. All right. My ultra slow laptop. No, I don't want a PAL TIA. I want an NTSC TIA. Sorry, I don't know the pinout by heart. Many apologies.
So the board you are working on is something like a Raspberry Pi or an Arduino?
The chip that you can see a small chip below 2 LEDs, I think. Right now, I'm not actually looking at the video. That is an Atmel Atmega 32U8. And that has USB firmware in chip. It's 20 megahertz, 8-bit. It has a bunch of breakout pins, and you should hopefully be able to see next to the chip all of the breakout pins. I was told it's a little bit blurry. Here, let me try and get this image onto my desktop so that I don't have to have a browser up to. There we go. Close some tabs and get some CPU back. All right, so I hear Charles, my housemate, talking about various different kinds of acid. It's hilarious. All right. Okay. So yeah, just to refresh or whatever. So USB here, obviously, and then into this right here, which is an Atmega 32U8. And then the LEDs are just for show. I can control them over USB or do whatever I want with them. Up here is an AtTiny 85. We use the AtTiny 85 to pull from the crystal and generate either a clock from the crystal, or we can generate an alternate clock based on the crystal. Up here and also down here are programming ports for each of those chips so that we can upload new firmware if we need to. And then we've broken out the pins from the Atmega right there to all of this stuff right here. I'm trying to position it in a way that maybe is this backwards or the right way? I can't tell.
It's the right way.
It's the right way. Okay. On my screen, it's totally backwards.
That's the right way.
So you can read that it says Retro Soundinator.
Mm-hmm.
Okay. All right. So over here you've got address and data lines and whatever, and up top you can see stuff like reset and clock and read write. So basically, all you have to do is wire up those breakouts to the actual address and data and whatever lines of the chip. In this case, that is, I just pulled up like a GIF that someone made of, you know, the derp. Is that the right window? Yes. Ta-da! So I'm just gonna like wire up everything straight to this guy and hopefully get it right. So I've got a bunch of these guys, which are jumper wires or DuPont cables or whatever. The number of data lines we have is 8, and the number of address lines we have is 6. So I'm just busting up a wire accordingly. 1, 2, 3, 4, 5. And actually, I might match it to the one that I already built, which goes from black to orange for data lines. And I believe these are from the same kit, so I can 1, 2, 3, 4, 5, 6, 7, 8. Yep, that looks right. So I'm just going to peel these. I'm just like literally, I don't know if anyone is actually interested in this crap, but
It looks
ta-da!
pretty.
Yay, rainbows, right? So, and then I'm going to use brown. I think I use brown for clock, and I use red for power on my other one, which kind of makes sense, right? And all I am going to do is literally take the board and just, you know, like plug everything in. So, I don't know, maybe I should like pull this back a little bit so that you can kind of see what I'm doing. So data 7, they're a little bit higher up, so you know what, this is going to be a lot easier if I just line them all up and hold them together. Ta-da! And on the other one, D0 is black, so I'm just like, hey, thingy. And I really just, yeah, almost had it first try. There we go. So now that I've got that, basically the idea is that all of these wires are my data breakout for this chip, and I can run it out to where it goes on the board. And the data lines are in 2 different places. So on the chip, data 0, 1, 2, 3, 4, and 5 are on one side, and 6 and 7 are on the other side. So I can just peel 6 and 7 back a little bit and have these all in a row. Data 0 starts at pin 14. You might want to mute your mic or turn it down, Patrick. Yeah, well, this is the internet. So pin 20 is voltage. Pin 19 is where data 5 goes. So now I can just get this nice and close to the chip. Oops, and they're not close to each other. Oh, almost. All right, so pin 14 is data 0 and pin 19 is data 5. Good. And then data 6, which is going to be yellow, is 33, which is over here on this other side. And data 7 is 34, right? So 40, 39, 38, 37, 36, 35, 34. Good, just making sure. All right, so now we have the beginning of that. Things that we also need to hook up include power, audio output, a few other things. So let's figure out what we want to do next. Next, I think we are going to hook up clock. And like I said, I did that with a brown wire on the other one. So now I've got a brown wire right here, and clock, this is not going to be on the test, but clock comes out of here. I can't even tell if this is somewhere you can see it. There we go. So just bust that out, and then clock on this chip. There we go, sort of.
Sort of.
And I'm trying to look at where clock is probably OSC on this pinout, which is 11. That makes sense. So and I don't believe clock goes out to anywhere else, but I do pull 5 volts off of, you can see this middle thing says 5 volts. So we're going to pull power off of the first 5 volt pin that we have. Well, technically, whatever, right? All of this is 5 volts. And 5 volts should get connected to that bottom pin. So down here is VCC. And that's good. And there should probably be let's see. Oh, wait. So I see there's another voltage thing. Also, my lights went out. Oh, that's because I unplugged it, which was smart of me. So I'm actually going to look up what VSS is on the TIA because I don't know, and I would rather be VSS, voltage safe than sorry. So this is the part where I literally just look that up. Oh, except I ended up at the person's image post. No, I want to see the page. Hello, laptop. I know you hate my guts. Laptop's like, hey, buddy. What's that? You need RAM? Sorry. By the way, shout outs to anyone that knows where this is. I don't know if you can even see this because everything is on a huge delay, but I'm going to take this link and paste it down here because that is where you can actually read about this thing. Ooh, check it out. You can see.
So pretty.
Yep. The tunnel of whatever it is. All right. Anyway, and that is, you know, like right back there. Uh-huh. Alright, back to here, and this is like, I actually know nothing about this chip, and I have to start from scratch here. So, someone is basically, hey, VSS is ground. Smart. I usually see it labeled as ground. I usually do not see it labeled as VSS, but I should probably hook up ground. That's probably a smart idea. So let's peel a black wire. And ground comes off of that top pin, pin 1. And I have a bunch of stuff that is labeled ground down on the bottom. You can see that there. So I'm just going to jump that over and, yeah, I don't know. Let's just put it on the middle something or other. Sure, sounds great. And chip select, I don't know if that really needs to be like, well, I guess we're just going to find out. So we've got clock 0 line is on, oh, we're looking at a different chip now. Let's look at the chip that I'm actually supposed to look at. Here's the TIA. Okay. Pins 1 and 22 are connected to ground, back to pin 22 because it's one of the chip select pins. I'm just reading something on Atari Age right now. So sync on the 6502 and the TI are totally different things according to this thing. Pin 11, which is, I believe, what I chose, yes, is for Oscar oscillator, sometimes labeled XTAL for crystal, and is connected to oscillator circuitry on the 2600 motherboard. This is an input line that feeds a 3579575 Hertz pulse to the TIA. I'm not sure if the Hertz value is exact or rounded or truncated. I'll be assuming it's exact. OSC signal is basically a high-low pulse signal, blah, 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 blah. Okay. Point is, that should be fine. Pins 4 and 26 are connected to the clock lines. Clock 0 is an output pin on the TIA. Clock 2 is an input pin. The TIA takes the OSC signal and uses it to generate a clock 0 signal, has a rate 1/3 of the OSC rate. This is done with a divide by 3 circuitry, although the circuitry usually multiplies the OSC signal. Blah, blah, blah. We might have to figure that out in a second. The 0s and 1s are low and high voltage levels. 6507 has no clock 1 output, and the TIA has no clock 1 input. So this, they're talking about multiple clocks. I don't really care about that. Pins 27 through 32 are for the 6-pin address bus. Oh, we haven't hooked up the address bus. Maybe we should do that. I used orange, yellow, green, blue for some of the address lines. So I could do that again. Let's see. How is that laid out? Oh, and I didn't even hook up the high address lines, but I'm probably going to need to do that as well. Well, that's all right. That's fine. So orange, yellow, green, blue, purple, gray will give us 6 wires for the 6 address lines. And we'll just hook those straight up to address 0 through 5. So over here, zero is orange again. So as not to mistake. Well, it doesn't matter. They're on different bundles. That's why I did that. Oops. Get all together. All together. No. My dexterity roll is short today. Okay, so we've got those address lines. And now on that pinout, address 0 is 32, right below the data lines, and it just counts up. So address 0 being orange on here. Let's hold all of these together. That just goes right below those. Again, dexterity is complete shit today. Oops, missed one. Right, okay, so that's our address line bundle. This is our data line bundle. Okay, and I guess we should hook up the read-write pin. Would probably be a smart idea. And I used a purple wire for that on the other one. Just kind of doing the same exact thing that I did on my other board so that it's easier to read and compare, I guess. So let's take read-write on here, which is going to be directly above the address line, and hook read-write up to the read-write pin, which is 25. And so 25 is read-write, which is skip a pin from the address lines. That's the next one. So that is this guy right here, 25. All right. Okay, the other two, I'm reading the chip select things. Pins 21 through 24 are used for TIA's chip select lines. Pin 24 is CS0 or chip select 0, which is active low, connected to the A12 pin, but since it isn't connected to the TIA's address bus, it doesn't increase the TIA's addressable memory space. Instead, it's used to help the TIA know when 6507 is talking to it. Pin 21 is chip select 3, which is also active low. It's connected to the 6507's A7 pin. We're not connecting this to the CPU, so I'm kind of trying to interpret how this CPU right here is going to be talking to it rather than, how a 6507, which is right here, would be talking to it, and kind of learn. Greetings, Jeremy Clay, by the way. Thank you for joining. The other two chip select pins or lines are CS1 and CS2. CS1 is connected to power or voltage and is active high. There's no bar over it. CS2 is connected to ground and is active low. Since ground is always low, CS2 is always active. CS1 is active only when there's power going to it. Chip select lines are used when multiple chips or devices are connected together, so they'll be able to know when they're being talked to, so to speak. That is, the pins on the 6507 are connected to the pins on the TIA and 6532 or Riot chip. The 6507 sends an address over its address pins and some data over its data pins. These signals go to the TIA and the 6532 simultaneously, so they both need to know, hey, are you talking to me? Chip select lines tell them this. So we're actually probably going to leave it in a state of always being talked to, which means I'll probably want to connect a couple of those. There is a bunch of stuff in the TIA that we're not going to use at all. So some of this might not necessarily be pertinent. One of the TIA's chip select lights is always on, CS2, which is connected to ground. Another chip select light is on only when power is on. You can think of it as indicating whether the office is open or closed. The other two chip select lights tell the TIA whether the address on screen and the data in the message tube are meant for it or some employee in a different room. He's using an office building analogy. Thanks, by the way, to whoever this is, CGT Gruff. C as in like an ocean, for explaining this in the Atari Age forums. So he is basically explaining how to read and write from the TIA. And since we're not really going to read any data, so we may not need to connect a lot of these, actually. Pins 35 through 40, I5 through I0, connected to the input port. These are used for reading the paddles, yeah. Odd 1 and odd 0. Yeah, maybe we should hook those up.
Can they hear you?
Pins, they can. They can hear everything.
Okay.
Why? Did you want to say something to the... Okay. Okay. So pin 2 is sync, but that outputs composite sync because this is also a video chip. We're not going to hook that up. Pins 5, 7, 8 are luminance. We don't care about that. Pin 9 is color signal. We don't care about that. Pin 10, del, is an input pin that only receives color delay from a potentiometer. So that is also for hue. So all of that is video. However, pins 12 and 13 we do care about, so that's our audio signal. And we should probably do something with that. So interestingly enough, we actually get stereo audio out of this. And so one channel, basically it's a two-channel chip. And by two channels, I don't mean stereo, although it does equate to stereo. I mean, literally, you get two-voice polyphony out of this chip. So each voice goes out to a separate pin, which we're just going to wire up to two different places, and that way we can hear sounds out of each different jack, since I've got two of them right here. So in this case, why not use a white and a red wire to properly denote left and right, so to speak, audio on pins 12 and 13. And I guess it doesn't technically matter, but I'm going to... Odd 0 is 13, which is technically the left channel or the first channel to me. So I'm just so that I can remember 13 is going to be white, 12 is going to be red, and that is directly between the oscillator and the other pin. So that's, if we look at this, should have had a little bit of foresight and done these in the order that I was, but these two guys right here, we're doing white on the bottom and red up top. So those are just like right in between the other stuff that we had set up, and the oscillator pin is right up top. And then just staring at this board, they're both labeled out. They don't really have numbers on them or anything like that. So I am just going to connect this directly to the first pin on the bottom. So that one can be right, that one can be left, because staring at it is, that looks like what we need to do. And then everything is already grounded, so that should give us, in theory, with the exception of hooking up chip select, which I might just do now, we have almost connected this entire chip. And that's neat. I'm looking at my other board and just trying to figure out, I have one other thing. I think Charles made a thing. Can't really tell. All right, so this is the boring part where I go downstairs and ask Charles why he did a thing on my other working board. I'll be back in just a second. Yay. All right. Scissors. There's more jumpers than I need. That's all right. Okay, so on my other board, just mirroring some things. There. And I've been informed that I should hold chip select to ground. So I'm just going to take chip select pin up here. Thunk. And look at my, I have like those 4 chip select things, which makes this very confusing. I'm going to look up a pokey pinout. Because I have a feeling this is going to give us some important information. Show me the pins. There we go. Chip select 0 and 1. There are not a chip select 2 or 3. However, 30 and 31. All right, so 30 and 31 on the pokey. I see. All right, so we're just going to hook up the ones on the TIA list that say that they should be going to power and ground. And this guy explained those as... Let me see if I can find it real fast. Okay, so 22, chip select 2, which is VSS. We're going to wire up to some power. How many of these do we have left? One, two, three, four, 5, 6, 7, 8. I want to keep this bundle. All right, so this one is the grounded one and goes on the second to last pin, which is 22. Here, let's put this 23 thing on real fast. 22 is that guy, and 23 goes over to 5 volts. Doesn't really matter where I put that. So as long as both of that has power, BCC has power, VSS has ground, and I guess that entire block, even though it says chip select, is really just a grounding deal. And pin 20 also has it. That's fine. Does it look like a mess yet?
Yeah, it's looked like a mess.
I'm hungry
Wires
for spaghetti.
everywhere. All right, Crystal is hooked up to a thing, in theory. Oh, Hangout says that it wants to run plugins, but it is running plugins. I don't understand. Whatever. All right.
Just ignore it.
Yep. It's working, so I just don't care.
That's all that matters.
Okay. Pins 1 and 22 are connected to ground. That's what we did. Pins 20 and 23 are connected to power. We did that. Pin 11 is OSC. We did that. Pins 4 and 26 are connected to the clock lines. And I don't necessarily understand why those need to be connected in addition to the oscillator thing that we already connected. I'm guessing because most of these, most chips from Atari anyway, offer the ability to select an alternate clock so that you can get like high or low noises. I'm not entirely sure that we're concerned with that. I mean, we sort of are, but 4 is an output pin. And what did they say? 26 is an input pin. I think we're just going to see if we get sound out of this when we connect it, and that's going to be the answer. If you hear a random laughing, it's not an evil genius. It's just my housemate.
Oh, evil geniuses sound cooler.
Today is my day.
There we go. We have a vampire evil laugh instead.
He just wants to return to the street.
All right. So we've got this guy. Technically, it is not necessarily programmed. Hopefully, it won't blow up.
I don't think it's a bomb.
And I'm going to unplug the programmer and just plug it in and see if it boots. That would be a nice thing, right?
Yeah, hopefully no magic smoke.
Is there smoke?
No, I said
Doesn't smell like anything's blowing up. Yeah, I just plugged it in, so I don't know if it is producing smoke. It looks like everything's in order so far.
Give it 10 seconds.
That's what I'm waiting for.
Sooner or later, it's going to go up in flames.
Let's see. Oh. Make. Okay. Not find device. Well, I mean, that's a step, right? All right, what device are you looking for? That might be a good idea. LS USB 8324. Well, it's trying to find it. You know what? I'm just going to try unplugging things and plugging them back in. That always works, right?
Sometimes.
8324. Well, it opens it, and then it can't. Maybe I should. Let's test this with the Poke board real fast, which means I'm going to need to edit that file again and look for the other board. All right. This is the wire from the Poke board. Unplug this guy, plug in the Poke. And that one appears, and then still cannot find device. So something weird is going on with libUSB. Maybe I should be doing this on my desktop, where I already, the only place I've actually tested it on is my laptop, not, or on my desktop, not the laptop, which is smart of me, of course. This is all about learning. Everyone likes learning, right?
I mean, I'm learning.
Hmm. Well, libUSB initializes, and then it gets a okay, so it tries to get a device handle. And this is the USB coding side. It has nothing to do with what we just hooked up, which is funny. Python. I have Python stuff and C stuff. Do either of these? Hmm. Nope. turns the handle to the USB device. Good. You may need to call in an expert. Patrick, I have to ask, are you just like running a YouTube video into a webcam device or something?
Nope, it's open MSX.
Oh, are you just playing games and then capturing it into the video stream?
Yeah. Is that a problem?
Okay.
I'll just switch to my regular stuff.
Okay. I was watching it and I was like, when it's in a thumbnail, it's just very small and looks like it's just kind of scrolling randomly through games and stuff. I didn't know if you were playing or just running a stream or what.
I'm playing some games here.
The labyrinth
Looks
caught my
like
attention.
Romance of the Three Kingdoms for a second there.
I was intrigued by the labyrinth.
Space Manbo. Nice.
Yep. I'm not sure if Jesse is familiar with the MSX platform.
I'm familiar.
Okay.
My father works on a lot of games and stuff.
Okay.
So we can see how good you are at Space Manbo.
Remember, I made the cheat database, right?
Yeah, I was going to say you have a trainer.
Yep.
Okay, I'm going to run downstairs and get Charles and ask him why it doesn't work. I'll be right back.
I will be right back as well.
I'll be playing Space Mambo.
And that is probably the problem. I will try it again. purple.
An ice cold Coke.
In this case, it is purple drink, because I live in the South.
I have never heard of that. Sorry.
Grape soda.
Ah.
The joke is that it is, since grape soda is purple, some people just call it purple drink. Or purple drank if you want to have a southern drawl of sorts. Although it always is a little bit discouraging when you see blue fizz because of the blue food coloring on top of a drink that is purple in nature.
Wait,
Obviously it's purple, right? But like here.
wasn't purple drank something with a prescription cough medicine or something?
I mean, technically, all soda was once developed. Like Coke and Pepsi and 7-Up were all purported to be a prescription or a medicine or, you know, an elixir at one time. And then they realized it wasn't actually doing us any good. Well, I mean, Coke had cocaine in it, so it was probably fixing something, right?
Mm-hmm.
But you know, then it eventually just became so popular that, you know, they had to take all the drugs out. So all we've got is, you know, caffeine, sugar, and a bunch of, I don't know, whatever else is left, flavoring. At least it's tasty and cold. All right, so I've been informed that the thing that I am doing that is dumb is I think I need to be root to be running all of this, and I haven't been, and that could be an issue. So, new top.
Nothing a sudo-su can't fix.
Yep, and that is exactly what I did. So now I have the Pokey board plugged in. So maybe I should aim this camera somewhere else so that you can see that. But let's see, how can I do this? We're going to move this guy, and we're going to unplug this for just a second so that we can see the new slash other board, whatever. And make sure this soda can is out of the way.
I was going to make a joke about a Poke board, like Pokemon.
I already made that joke on Twitter. Did you see it? Or Facebook? Or,
sorry, I didn't see it.
It's okay. I know you don't love me that much. So yeah, maybe I don't actually need to unplug the board that I unplugged, but I would like to also plug in this one. Move this over just a little bit. All right, so now we've got this guy, right? Wherever the camera. Is this a, I don't even know if this is a good angle. It's probably a shitty angle. Whatever. red wire is plugged into the PA speaker. Well, that's cute. Listen to that noise. And maybe this would be a better angle. I don't know. Whatever. What would probably be a way better angle is if I could, well, I guess I could maybe set this on top there. So, huh. Can you hear that at all? I don't even know.
Are you watching Star Trek again?
Let's,
I hear it.
So the very cool thing about that is I don't think that's the actual audio output, but it's pretty cool sounding. Let's see if... No, doesn't matter which output. Huh. Let's see if I can just plug it into the other input. Well, it's definitely louder. Maybe let's run the Python thing. Well, that was cool. Okay, so my test app is running, and I have no idea what that other sound is. I have this dumb little keyboard thing, which hopefully, you know, like... But, you know, if you hit a key it doesn't recognize, it just yells at you. Kind of, yeah, any key, really. But, so that's what's supposed to happen, with the exception of, I'm not actually sure why we're not, you know, like... Oh, I need to reboot the board. So if you unplug it from clock, it just... it doesn't know what to do. So yeah, really not entirely sure what that that cool background noise thing is. So all right, let's.
It sounded
Sorry?
really cool when it went to Poly. Sounded pretty nice.
Yeah, which is kind of awesome because many synthesizer noises that are cool are mistakes, and that was definitely a mistake. But so all right, so I wanna figure out what's going on with my TIA board now because I feel like I've got enough of it hooked up that I should be able to figure this out. So I'm unplugging one of the boards, this board, right, which you can't really. That's a nice shot of my ceiling light.
Oh yeah.
So
Fine.
so if I plug in this other board, I'm going to move some stuff. We give this board. There we go. So now we're trying to figure out how to get this board working, right? And I don't even know if that's in the frame. Shrug. There. Something like that. And if I plug into USB, it boots and initializes, and this is a different hardware ID, so I have to change this. Back to what I changed it to before, which is ABCD and 8324. I'm not really sure why we chose those numbers, but whatever. All right, so, and this may not actually work because all of my software is written to talk to the Pokey and not to this chip. And there are definitely some modifications we have to, well, I'll have to make at some point. But I'm hoping that maybe I can send it the right commands using something like this. Boot up. Well, it seems to detect it, but I don't get any audio. And actually, I should check both jacks because that's the. We should be using channel 1. Okay, so I don't get anything out of there. No register commands seem to, and I mean, it's totally not the same set of registers, but I wanted to see if it would give me anything at all. It doesn't, but we get, we do get, it recognizes it. Everything seems to compile right. I'm going to see if I can flash it. Now that I'm root, maybe this will actually work. Nope. So I still need to figure that part out. But it sure is cool to be able to get that Pokeboard working. That was a, you know, different thing or whatever. Well, let's plug that one back in and just, you know, like this board. Yep. I might just need to tie something down. Like, I might be hearing internal chip spew. Okay, so change this back to the other chip. Well, at least there's that. All right. Well, okay. Well, I think that's probably enough video capture for this video. I have to figure out why certain things aren't flashing on the other board, and then I need to figure out which memory addresses I need to poke on the other chip and send register data out to it and whatever. And a bunch of that might be for another day because I don't know how long I have to get this other board ready. I might just set up for the synthesizer meet with one board, or something like that. But thank you for watching and hanging out with me. I think when I hit stop broadcast, this is going to go up on YouTube. I have no idea. But,
Most likely it will.
yeah, I might want to make it unarchived. I have no idea. We'll find out. Whatever.
I mean, it's still broadcasting on YouTube.
Yeah, so I'm actually, the streaming interface, I'm using it exclusively through Google Plus and Hangouts on Air. But then YouTube latched onto it for some reason. Which is good because originally I wanted to just use the YouTube live streaming thing, but then I figured since I wasn't using YouTube that it wasn't going to go out on YouTube, and well, technology. So, all right, well, if this appears on YouTube, great, and if not, then I'll figure out how to get it up there and maybe cut the video to pieces so it's actually interesting. But if you're watching this and you're hearing this and you're watching it on YouTube, then maybe you're watching the uncut version because it went up and I didn't know about it. So, hello world. We'll see what happens next time. I'm going to hit the stop button, and I'll probably do this again if I get some more stuff working.
Okay.
Bye, everyone.